Thanks for joining this afternoon panel session. And I'm going to keep it short. I'll give you a quick kind of an intro into the topic on data infrastructure in the automotive industry. And then I'll ask our illustrious panelists to come on stage, and we're going to have a vibrant discussion. We also have the capability for you to ask questions, and we're going to play those, and then we're going to go into an interactive session at the end for the last 15 minutes. So I hope for you as a developer at this WeAreDeveloper conference here, it's going to be interesting and stimulating to see what happens in the automotive industry. If I can get my slides up there, I could give you a little slides. Here we go. Let's go back. Clicked. So, quick intro on myself. I'm the Chief Platform Officer at HERE Technologies. HERE Technologies is a company that historically was basically the inventor of electronic maps in the car, about 25 years back. Today, this world has massively changed. The static map, as we know it, has completely changed, become a very dynamic environment where the car is always connected, where the map is potentially self-healing, where content comes in on the fly, and where the map becomes kind of a living digital object. That is a journey that we as a company have been taking, and you see a couple of statistics here down here. We are present in about 200 countries. We cover about 100 million cars right now across the world. And to actually achieve all of that, we're already today in a world of very, very heavy data crunching. Just to give you a little bit of an idea, we have also these cars that run around that map the streets and try to create the best user experience, map experience for our consumers. And just that in itself is something where you create about 700,000 data points per second, right? Where you create 28 terabytes of data on a per-day base across all these cars, 28 terabytes, okay? That means you have to take those data, get them to data center, process these data, and extract then, points of interest, street-level navigation, etc., all of that. So it is a world, the world of cars, the world of mobility, is a world of very, very heavy data crunching. And of course, all of this, is used then in the map context, for example, of course, to move humans from A to B. And all of us who use this in urban environments, we all know that the level of sophistication and the level of demand that we put to these systems is augmenting every day. In the old days, it was take me from A to B. Today, it's can you please include urban transport? Can you please include, for example, car sharing? So I might want to use a car sharing and then use an urban transport. And then, by the way, I'm also looking for latest point of interest, latest club, bar, restaurant, shop, or whatever that has just opened maybe yesterday, and I want to have in the context of my map. So we humans drive this topic. The cars by themselves drive the topic in various shapes and forms, because of course you want to see, where's the next petrol station? Oh, by the way, can I also see the price tag on that petrol station? So I'll take that one, or maybe I take the next one because I have a promotion. And then eventually, we're moving into a world where the map and any kind of mobility surface is going to have a whole different level of sophistication. Right now, today, if you're outside in Vienna, you don't see a lot of drones flying around. But that's basically only a matter of time. Because, regulatory, the FAAs of the world are working together with the industries. Industry is pushing hard. Security is, of course, of utmost importance. But down the road, in a couple of years, we'll see these drones flying around, delivering goods, basically putting us into a new world of mobility. And if you think for a second, and this is just kind of like a schematic representation here, if you think about what's happening there, you have to kind of also use the airspace and map the airspace, and also especially map the air-to-ground transfer. Where a drone comes, delivers something, or has to recharge as an EV charging station, and goes, finds the charging station, and then is ready to go and carry goods across an urban environment, or maybe not even an urban environment, long-distance travel for medical devices or medicine, etc. That needs to be managed. And you're talking about a highly automated world. There's not humans flying these drones, not human orchestrating all of that. This will be a world that is basically run in a very, very autonomous fashion. So all of that demands for very heavy data processing in the context of location, in the context of exactly knowing where am I going, and what are the circumstances around me, what terms and conditions are around me, what's the weather, what am I allowed to do, what am I not allowed to do, in terms of regulatory, etc. So huge cooperation here also between the cities. Every city, meanwhile, calls itself smart city, and the industry at large. And then you need to handle, of course, all kinds of situations. This is just recently what happens sometimes in Berlin when the weather gets a bit nuts and crazy. The challenge is, if you look at urban environments, large cities, whether it's in Asia or also in Europe or in the United States, you see that due to the density of traffic, density of travel in general, situations escalate very, very fast. Situations, whether it's traffic jam, etc. So the demand for highly sophisticated location-based solutions that allow to handle these kind of situations is very, very important. Just give you a little bit of an idea. If you look at this movie here, it shows all these spots. This is from our data that we collect from car sensors. So we get them from cars into the cloud. It's just raw information that shows how the cars are moving across an urban environment in the Berlin area. And of course, every one of these blue spots that comes up has a richness of data that we then use to process traffic, to process, for example, weather conditions, to process, for example, in an urban environment also, parking spots that allow to then, for example, say there's a parking spot around the corner, and if you want a parking spot now, if the probability is 90% that if you just drive across the street and take a left, there will be a parking spot for you, right? So car sensor data, or sensor data in general coming from cars and or devices of that nature, allow and will give opportunity to create enormous new business solutions. Just to give you a couple examples of things that we have been doing recently, working with especially our shareholders here, give you an idea on what you can do with some of these car sensor data. This is something that is going live in the next 1.5 years. And what's happening here is we use sensor data to actually augment the quality of the driver experience. Take one like hazard warning, like slippery road, for example. Most of the cars today, when the temperature drops below 3 degrees Celsius, it goes like ding, and then it has maybe the street will be a little, slippery for you, which is a very generic statement, might be true, might not be true. If you look at what the car sensor data can give to you in terms of, wheels spinning, etc., you can calculate, getting those data into the cloud, you can calculate very precisely for the cars that, for example, are on the road behind, what is going to happen down the road. And you can bring a statement that says, hey, watch out, ahead of you, 100, 200, 500 meters ahead of you, there is a slippery road. And already put potentially the car in the right state and give an alert to the driver so the driver exactly knows, wow, there's danger ahead and not, some generic danger. Look at road sign recognition. Some of the cars today have these little cameras, and then you see the dashboard, that the speed just went to 30 kilometers an hour or back to 50 or 100 or 120. That is kind of nice to have, and it helps you to kind of adjust the speed. But what do you do when you have autonomous driving and you have a construction site on a highway that is a moving construction site? We as humans, we look at the horizon and we go like, oh, there's something coming up, and I'm gonna, slow down a little bit and then see what that is, and then you recognize it's a construction site that's kind of maybe moving on the left lane. An autonomous car, if it does not know about that, it's gonna keep on speeding at the same speed, and then it's gonna recognize there's something going on, and potentially take a strong brake and potentially generate an accident. So propagating these information to the cloud and the car without even seeing this, knowing already, there is a construction site behind the next curve, and I'm going to just take already, take it a little bit slower, slow down, adjust my speed, will allow for human-centric behavior of autonomous cars. So this is not just, all these scenarios are not just meant for the current cars and for the current driver experience where people are still completely in charge, but also for the next level of cars that we will see. Just a set of sensor data that you can look at that are relevant for example, business scenarios in the autonomous space that you can use to, for example, if you look at the windshield wipers, it gives you an idea on what kind of weather conditions, so whether they're on stage 1 or whether they're going very fast, gives an idea how much rain is coming down there. And if you have this with a good statistical level, you get basically weather for free. Weather terms and conditions almost for free, at least on the ground. If you couple that with the temperature, with the humidity, you have a very good, very precise representation of weather. When you look at the suspension system of a car, that gives you basically road roughness for free. I mean, most of the cities have specialized cars, expensive cars that run the streets up and down once in a while and measure whether there are potholes and what the road roughness is. And cars would basically generate those data almost for free. Of course, you have to kind of process them and all of that, but it's inherent in a car that it gives you all this high-quality data. Another aspect that comes into play when you talk about data in the context of cars, and especially in autonomous cars, you need a whole different representation of the environment. It's not enough to know, oh, there is a lane. What you need to know exactly how wide is this lane. Is there maybe some construction on the side that limits how high is it when you're running a truck, etc. So you have to have a very precise lane level description of the environment, and only then can you have a car run into that alley and then do the dynamic adjustment with the computers that are underneath the seat. And that is something that is also happening, puts lots of challenges for developers, because there's a lot of AI involved to actually recognize out of imagery what the streets look like. There's a lot of very heavy data processing, again, in the terabyte space. And then ideally, and I'm going to close on that piece of information here, ideally you want to have a self-healing map. So you go out, you measure once, but then the car gives so much richness, the collective car setup gives so much richness to the map that it starts self-healing. So cars recognize, oh, there's a change. The map tells me we're like at 50 kilometers an hour as a speed limitation, but the car sees it's 30, plays it back. We start doing some statistics. If we get that signal 10 times, yeah, it might be that it has gone from 50 to 30, and then we inform all the other cars in that region that speed limit has changed. So you ask yourself, is this map then a human-centric map or a human-built map? No, it's going to be a completely autonomously created map. And that's, again, a huge challenge to software development, because, of course, you have to kind of put all these systems in place, whether it's AI systems for recognizing, imagery, whether it's large, systems that allow for, 999 availability, because if those systems go down and autonomous cars are dependent on those systems, you might have a huge challenge to actually keep your system going and keep your customers going. I'm going to close on a little video here. We use this video to actually kind of summarize a little bit, how an urban environment might look like in a couple of years. This is built on some imagery around Dubai. Dubai is a place that is very, very advanced and testing out a lot of data-centric and digitization scenarios in the context of smart city, in the context of cars, in the context of public transport. And this video kind of summarizes a little bit what you can expect down the road in terms of scenario. It's a bit futuristic, but it covers some of the key scenarios. So with that, I'd like to close down on my little intro keynote. Thank you very much for that. And I'd like to ask the panel to come on stage. First, foremost, in no specific order, but Klaus Straub, CIO of BMW. Welcome. Walter Kreisel, the CEO of Kreisel Systems. Hello, please. And Michael Fausten, VP Engineering Automated Driving at Bosch. Hi, Michael. Please. Ich gehe auf die Seite, ja. So, the idea was that the panelists kick it off with what we call impulse statement. So they kind of like, bring to stage their ideas around the context that we just kind of like have set up. And then we go into a dynamic discussion. As I said, at the end, we will also have the ability for Q&A. So if I can ask Mr. Straub to kick it off.
Yeah. Well,
and then we go around and then we go into the panel discussion. Thank you.
Thanks a lot. It's an honor to us from BMW to stay here and to be here also a big contributor to this fair. Well, digitalization is one of the most driving, propelling changes in the automotive industry. You mentioned it before. On one side, we have for sure, when we talk about digitalization, the change of the product. And at BMW, we divide more or less digitalization in 3 areas where this revolution, or we can also say disruption, is coming. One disruption is the car. The car, you saw it at the last areas with autonomous driving. The car will get part of the internet, will get an IP address, will get a device more or less, but a device which has to be secure with all kind of things in the future. The second big area, which will be a big revolution, is Industry 4.0. When we talk about product development, when we talk about production, when we talk about sales, after sales, we will have information flow from product development to after sales on one side, but also the machines will have an interaction in between. Combined with, for example, bionic generative design, combined with additive manufacturing, we are ahead of a big, change in this whole value chain. The third big change and disruption is the customer itself. There you will ask perhaps why. Yeah, well, today we have currently 8 different channels, customer channels worldwide in every country, in every area. Just take new car sales, used car sales, take the workshops, take, for example, the car where you have connection to the customer, take our digital services and so on and so forth, financial services, and we have to integrate these channels, and this will be a mess of work before us, and focus on the customer, because currently, and it will be also in the future, we have different players in these channels. This is one dimension when we talk about digitalization. The second dimension is digitalization will change our way to work. And we call it at BMW, we have to speed up and we have to get more flexible. And then that's the reason why we are here on the fair, on the WeAreDevelopers conference. We are migrating more and more to a tech company. We are coming from a mobility and service company and migrating to a mobility, service and tech company. And when I say we, that's also my colleague from the development area who is on board, responsible for onboard IT systems, then the colleague who is responsible for digital services and for autonomous driving. So we for our driving have set up a program called 100% Agile, and we are setting up with the new technologies, and we are searching developers and increasing more or less our staff dramatically to drive this company to a tech company.
Thank you, Klaus. Wolfgang.
Hello, also from my side. My name is Walter Kreisel. I'm proud to sit here with you all here, to see that the audience is pretty 100% full. And I'm also proud to sit with you here together because we are a really young company. Our company was founded 3 years ago. We are now close to 160 people. And Kreisel have 2 divisions. One division is the electric division. Here we build battery packs and mobile applications. And the second division, where I am the CEO, is making the ecosystem around the battery. That means that the battery can communicate, that the battery can build services. And together, the Kreisel Electric Systems offers in the B2B for tier ones, car suppliers, also energy grid suppliers, energy independent providers, so everybody who wants to run a business on energy and data-driven business model. And why is this so important? Is because the renewable energy is not only green. Renewable energy have the big advantage if you can make an energy logistic. That means with the battery, you are now supposed to make energy logistic, and there is the car, one major important thing also. Then you can store the energy, and if you can store energy, you can have every time, everywhere energy. Because the car is also getting electric. And between this ecosystem, we offer, so we are the core of the bottom technology in hardware and software. And we use software, for example, one example is if you have an electric car, or if you have a home battery or an industrial storage, then your battery never is running 100% of cycles. And if you run only a battery 60% or 70%, if your battery can call to other batteries, they can offer probably services for different solutions. That means the funny thing is on electricity, the car and the infrastructure is now electric. That means if they connected together and it's driven on renewable energy, it's going 10 or 20 times cheaper. That's the main thing. And it's green. And yes.
Thank you.
I think more we will discuss in the round.
Thank you, Walter. Michael.
Yes, warm welcome as well from my side. Great to be here and to be discussing with you about digitalization, digital world of automotive industry. I'm working at Bosch since more or less 20 years now, almost all the time in systems engineering, creating new products in the context of safety, agility, driver assistance. And since 2011, I'm working in automated and autonomous driving technology. I'm heading now the development team from Bosch, which is in cooperation with Daimler in creating the next automated autonomous taxi for urban applications. I must say that step by step, when starting with automated driving, I understood that automated or even autonomous driving is not just another product that we are bringing into the car. For me, it's the boost of the digital revolution of the car. In the past, we could create products which were like kind of standalone. Probably we were networking some piece of the chassis like the brake with some piece of the driver assistance like a camera or a radar sensor. We could create a quite nice of a product. You would call it ACC or lane keeping. But what autonomous driving is doing with the car is a complete revolution. First of all, the car will be connected. It will be a crucial part and integrated element of the Internet of Things. It will be creating data, tons of data, because if we do autonomous driving, we have up to 40 or even more sensors in the car which will register all what is happening all around the car all the time. And this is a huge value to have all this information about the world. I think Peter pointed on that in his introduction keynote. At the very same time, we need lots of data. You pointed on that as well. If you want to drive safely and autonomously through the world, you will be consuming data, and this data has to be reliable, it has to be safe, and it has to be secure. So the car is an integral part of it. Secondly, the vehicle will, or the functionality of autonomous driving is so much dominated by software, way more than any of the other products that we have ever done. The control units that we are providing now for this new technology are 100 or even 1,000 times more powerful than the control units we had in the past. So software becomes the dominating part of the whole system. And that means at the end that as well the way how we develop our products needs to change. We need other competencies, we need other people, and we need other styles of working and cooperating together. It's not the V model, the classical V model engineering anymore. We are applying agile methods. We are applying state-of-the-art, hopefully, software engineering methods. And these, say, old companies of the old industry have to learn all these new methods, which is a really challenging but as well fascinating change. And I would say last but not least, it offers as well new cooperation models. So to sit down with an OEM and not work on the basis of you specify, I execute as a tier one, but we sit together in the very same room and find the best solution jointly together. That shows us that the industry is moving into new cooperation models by this technology.
Thank you, Michael. Okay, so let's now open up the panel discussion. And the first kind of like topic we would like to kind of tackle here with you guys is, if you look at the environment out of which, for example, the autonomous, the cars, etc., and the autonomous cars going down the road are going to be, built. The factories, the whole ecosystem that is needed to actually build and create that new world. Me coming from a background, I have worked for almost 10 years in SAP, and SAP, of course, as a company, has been, looking at all the logistics and automating at that time and digitizing factories and supply chain. And now, 10 years later, I have the impression that we're starting basically kind of all over, because the demand for flexibility, speed, rapid reacting to customer needs is so high that we're basically going to a new level of digitization across factories and businesses in general. And so the question to the audience would be, to the panel here would be, what is happening in the digital supply chain? How is it adapting to those more nimble scenarios? How is, the topic of smart factory, how is that one adapting? We should maybe always, when we look at how we want to tackle this, keep the developer in one eye, that we say, okay, what does it mean for a developer who comes and works for one of these companies? What are the challenges for him in this new environment? So maybe I start with you, Michael.
Yeah, digital factories, industry 4.0 is probably the point that you're touching upon. We are facing a very strong demand to more individualized products, more on-time delivery of small batches of products, which need to be highly flexible in the industries. Since many years now, Bosch is working on this Industry 4.0 technology. We not only develop this as a product, we apply it our own. We have very highly equipped companies and factories. That means that equipping machines with sensors, creating all the digital environment, how to collect the data, how to handle data into a cloud, that is crucial topics of Bosch. We are working on our own industry cloud. We are offering an industry platform which allows us not only our own factories and plants, but as well to our customers to create their own ecosystems. What does that mean to the work of our engineers? The competence of how to connect machinery to the internet, how to collect the data, evaluate the data, handle the data, that will be a very crucial working task for all our engineers, which in the past probably were building mainly machines, and now they're working on some items which are connected to a cloud.
Can I have a quick question? What is the role of a data scientist in this context, next to a developer?
Data scientists is as well a group of people that we are strongly fostering and building up, because all the science or the value of this Internet of Things and production obviously is in the right way how to analyze the data. So what we need is people who know how to take a look into data, how to manage data, and how to extract information out of data. Obviously as well how to be sure that the information you extract is correct and right. You can do many things and analysis out of data, which doesn't mean that your results are correct. So knowing what is the right thing to do is important. And handling of data as well means know when can I delete data. Because if not, we will create tons of graves of data, which will result in heavy investment of storage, which you will never need anymore.
Thank you. You as a CIO of BMW, what's your challenge on digitalization in the factory and smart factory, etc.?
Well, as I said, the industry 4.0 is the whole value chain from development of cars to production and to the sales, but also the connection to the services. And when we talk about this, especially on the supply chain area, first we have to think about we need in future and we need today an overall IoT architecture. The basic technology which you see here on the fair, like blockchain, like big data, especially artificial intelligence, but also virtual reality and augmented reality, are crucial competencies we need to build up more or less an architecture, an IT architecture, to use the advantages of this IT, which drives more or less the factory into the future. Now, why do we need, for example, artificial intelligence? Predictive analytics is one big and crucial point in the production. Just think about predictive analytics in the maintenance area. So we predict when we need the maintenance from machines, but we predict also what I said before, when does a product has or part has a failure or not, and so such things. We want to integrate, and when we go to a supply chain, we talk not only about the first tier, for example, as Bosch, we talk also about the second, third, and fourth tier supplier and what we need together. For example, and where we have to work closer together, blockchain technologies, where we have a transparency and also a trust over the whole value chain, because if the fourth tier is bringing not these parts, this third tier and second tier, and then the first tier, and to us, our production will fail. And it's so closely linked. We need advanced these information to react very proper with our production. And when I go to production, well, the product development will be integrated closer into the production. As I said, generative bionic design will be one big thing where you need artificial intelligence, where we need software engineers who understand more or less with artificial intelligence which parts could we, how can we support the engineers of the cars to build up better products. So it's more or less the whole value chain which will be affected with Industry 4.0.
Walter, as a young company, are you basically a digital native when it comes to the hardware part, the factory part?
That's a pretty good question. I think you need all of this. Because I think the future is very interesting, because it will be cheaper and it will be greener. So there is a win-win situation. But on the end of the customer side, I mean, that's from all developers, the goal is who will have on the end of the day, the cheapest driven kilometer. Because if you have now a really nice closed value chain between production and the services, and it gets transparent, it will be very hard for all those car companies, because that is a very big challenge. Because the question is only how many money they burn with software. And if software is a so big part, right now it is the battery, the big part of money on a value, but this will go down. But the software probably is going up and up. But if we can share a car and we can run it on renewables, it's going cheaper. So I think that's very interesting. And without digitalization, it would be not possible. And I think that everybody could drive a car, a BMW, without paying it. So you only pay your BMW on the gasoline station. It could happen 20 years ago also. So this is probably not new to share a car or to rent a car, but it's more going into services. And I think if you look to the internet, what's happened with the internet? The internet is for free. You need data centers and data storage. And then you have the services. You pay for Netflix or driving a car. But it's the same on electricity. You need cables, you need wires. It's electricity. It's driven on renewables. So that means if the PV system or wind turbine have a break even, it's coming to zero energy costs. And then you have the battery storages, big ones and the small ones, the decentralized ones. But the value are the services. And that means then you only pay for the services, because right now you don't pay the taxi driver and you pay him €2 for the gas. Yes, so you only pay $6 by an app for driving. And so this is probably, we are only on the edge of technology with the battery and with the battery connection software. But to close this value and make it happen is a really big thing. Opportunity.
What you address from my side are two big areas. One is more or less the product itself, and in the past it was easy. We had Bosch and BMW, and we built up a car, and it runs, and you had no internet connection or something like this. Where I totally agree to you is that the number of code lines in a car will go expenditure above. So software will drive more or less. Currently also 80% of the innovations are coming from software in the car. But what is also changing, and that's a revolution, the car will get a part of the internet, and when I see it in an IT architecture, it will be an IP address in this whole architecture. And we have to integrate informations from the car into the backend, and from the backend to the car, from the car to the next car, and so on and so forth. That means this connectivity and this exchange of data with these methods we have and the technologies we have now. We didn't have it in 5 years ago or 10 years ago. What we have now will, and they are totally agreed to you, will revolution more or less the whole mobility area. And then what you addressed in the second part was the services. There we will see which kind of mobility services will jump up with shared mobility and ride sharing and reach sharing and all these kind of things. There we will see what is coming up, and this has to be developed.
Thanks.
One thing,
Yes.
it's interesting, because if autonomous driving cars, they drive with electricity, and it becomes 10 times cheaper, we need 10 times more cars, because one kid is driving to the violin exercise, and the second to the football club. My mother is driving to Linz, my father to Vienna. My grandfather is probably driving to the hospital, and my car is alone driving for my shop.
There we are happy when we are
the
needing
car
10 times a car, so
as
we
well
are
for
happy.
much more time. So
Yes, but the
today your
demand
car
will
is two hours a day, you will use it, and the rest is in the garage. And if we have like autonomous taxis, they will be working hopefully 24/7. Well, not fully, but we expect 18 to 20 hours of operation time. That means the renewable, the phase when you have to renew this car is way shorter than today's usage of cars, which is, by the way, very, very good, because you will never finish to develop a car, because as you experience new situations, probably even tricky situations that you couldn't handle, then immediately the information gets back to the engineers and say, okay, there's a situation you have to solve, we have to update the software. I think something for smartphone is pretty normal, but who was thinking about updating on a regular basis the software of a vehicle, a driving software of a vehicle in the past? So we need to learn how to get this information back, generate new safe software, and then have a safe update into the car. So
You're totally right, but the only difference between a smartphone and a car is, and you know it sometimes, these operating systems,
yes.
the smartphone is crashing and you have no problem. You make it out and switch it on, switch it off, switch it on, and then all is good. But a car, when you are driving, switch it off and on is a little bit tricky. So what's important with mobility that you have, and this will differentiate a secure and what you said, a safe mobility.
So we do not want to have Control Alt Delete in a BMW, is it?
Pardon?
We don't want to have Control Alt and Delete in a BMW.
I don't know.
I mean, human security is the main thing.
Yeah.
Yes. But the other thing is, if everybody remembers the Apple updates stuff with the battery, so that the Apple iPhones, because you said iPhone or a smartphone is a different thing than a car, but everybody who have old iPhones or old iPads knows that Apple is doing the software on the battery cycles. Yes, so also that would be possible on a car. So it depends. You do it for your customers or do you do it against your customers?
Yeah.
And that's the thing you control directly down to the production time.
I'd like to pick that. I think it's a good discussion to go to the next kind of group of topic, second group, which is about trends and also the feasibility of trends. And I'd like to, especially in light of what you just said, just share a little story that I experienced 2 days ago. I got a new car, pretty sophisticated car. Have it now for like 2 weeks. I'm not going to share the brand. And I was in Berlin on one of the this big 4-lane streets, and I experienced on the dashboard that I wanted to change something, and it didn't change. So you could see there's something that is stalled, and I stop at the red light. The engine goes off, automatic, shutting down the engine at the red light, and when the light went green, the car wouldn't restart, and nothing would happen. So it was completely blocked. I started to go outside the car, try to close the car. It would not react at all. And so they have this nice button, so I get connected to central call center. Make the long story short, they gave me some kind of alt-delete thing, and that didn't work. Meanwhile, the traffic was piling up. People were horning, and
you got nervous?
And you get a little nervous. After 15 minutes, without me doing anything, it goes like, and this car came back, and boom, the engine starts, and I could drive. Make a long story short, this was 100% a software problem, 100%. Okay. I then when I arrived home, I scrolled to all the menus. I found a button that says software reset. I pressed that button. Then everything starts working, and finally tomorrow I'm going to bring it to the shop to see what's going on. But the punchline is this is a huge piece of driving software, and it got caught in some kind of like whatever loop or memory leak, I don't know what, and that's what happened, right? And so that as a starting point, and then I would like to start with you and ask you, in the light of what we experience, when are we going to see really autonomous cars driving, especially in urban environments?
After this introduction, I would probably be very, very careful in making a statement, isn't it? Well, I think autonomous driving will come step by step. Already as of today, you can see that we have first so-called level 2 functionalities, which means that the car basically does the driving job for you, but you considerably should pay attention to what the car is doing, because still there's no guarantee that it will restart. We are currently working on the next generation, especially for highway applications, where we can really hand over the driving responsibilities to the vehicles. You will see that coming pretty soon, especially for traffic jams. So where you can really sit down, relax, and the car will do the driving. The next step will be then, say, beginning of the next decade, to have that on free driving on highways. The urban autonomous driving is a similar technology, yet a completely different branch, because for the highway driving, you're in the range of 15 sensors roundabout, and still a doable amount of sensors. If you do the fully autonomous driving, you're way beyond that, 30, 40 roundabout sensors that you might be needing. So technology with higher price as well. So that is a parallel development branch. We would foresee that as well. You can see several countries making announcement, companies making announcement in that area, beginning of next decade until mid of next decade, to have introduction into the market. And then we obviously will see how that will evolve over time. So mid of next decade, not only having the high-end vehicles doing this highway driving, and towards end of the decade, most probably having autonomous taxis in most major cities.
Okay. Walter, in that light of trends, what would like a full electrification at the end look like? You know, if I look today for like electric plugs in the city, there's one around the corner, there's one maybe, you know, 2 miles away. That is not something that scales if I would imagine that everybody has an electric vehicle. So how will it look like if we would go, you know, in a massive adoption of, you know, electrified mobility?
Our vision is to electrify the world. So this is probably a little bit close to this, but you have seen it on everything. If you see so many things are from beginning electric. So a CNC machine, for example, is not driven by a fossil engine. But so many engines are since they are here electric. And I think electricity is the only way to have less hardware, to have more efficiency, and it's the only way to run it renewable. And with software, you can run it with cheaper renewable as well. And so I think if we make water or heat or cold, so already a heat pump is electric, then you have batteries everywhere around you because you have electric cars everywhere. And then you have batteries everywhere also in commercial and industrial application, because there is one example, a pump water power plant. So everybody knows a pump power water plant is on the hill, costs 450 million euros for 150 megawatts. You can build this 150 megawatt pump power station with the double efficiency for the half price right now. And the main advantage is, so you can build 300 megawatts for the half price. And the thing is, the battery is going cheaper and cheaper and cheaper. And the main advantage is you can use the pump power plant, the big one, decentralized in 100 or 1,000 or 10,000 small batteries. And let them link them together to make one solution. And so this is the thing where the electricity is the main energy to drive all services.
Quick question on that one. So are we looking at a very, very highly networked, connected world to actually make this happen? In the sense also for developers, it's a challenge to actually connect all these worlds.
It's a very it's a big challenge. Right now, I think we don't have so we need 5G, for example. So we need 5G, much faster connections. We need much more bigger data centers. Yes, and but as long as it's driven on renewables, again, it's okay. We can do this without the problem. And so for all developers and all software guys, it only is the question, I think you told it in the start, who produced the efficient code in 3 or 4 years, yes? Because if you see what is artificial intelligence, artificial intelligence in my mind is our artificial results with a scientist together. So right now, artificial results with a scientist are artificial intelligence. But if we can divide this to one solution made on a computer, then we produce much less code, bad code, to can communicate in the way, communicate as fast. Because you can tell us this probably, the computer right now for autonomous cars needs, I hear that 50% of the electricity to drive. In the end stadium right now.
Yeah, at least you can have scenarios where you have several kilowatts of power that you need for the computers in the car. Yes, so it's considerably more than we had in the past.
Yeah, Klaus. In terms of trends, there's this famous statement that was made a couple of years ago that at one point in time, I'm not going to pay for the car, I'm just going to pay for the services. Like in other industries. So what challenge does it pose to all the systems that support the business of an automotive?
I think the discussion what we have is always what is the vision and the picture of the vision, and when does this vision happen?
Yep.
So and in between we will have not black and white, we will have gray colors. Just take electricity or electromobility for sure, and I totally convinced and agree. IT or electromobility will drive IT in the cars. But when I see the current production worldwide of cars, light cars, is approximately 70 million worldwide, 75 million worldwide. and we have several countries where we do not have the electricity infrastructure to boost that. So there we need combustion engines. So that means we will have black and white. Now going to services, mobility services, well, this need for sure an integration also between the product or between the car itself and the internet, and drives more or less the connectivity, but also there we have a gray world. We will have regions where mobility services or shared services will not happen, and because it's not from a business point of view difficult to make their proper business case, but there will, or we have currently areas, just take Berlin, in your area, Berlin, where we have many car sharing companies and where we're very successful, and in these urban mobility regions, these mobility service business models will be successful. So, and this is the difficulty for us, to cover more or less all these different requirements, low infrastructure, high infrastructure, urban, country, and so on and so forth, and build up the products for all these areas.
So it's a raising complexity to some extent.
For sure,
Yeah,
for sure.
For sure, yeah.
For me, a question to such a big company, BMW, where we look up and this motivate us, is if a car drives autonomous and you share it, probably I don't have to use a big car a whole year for driving it 2 times a year. Yes. So the thing is, if the service of to use an autonomous car with a brand, I mean, because I love brands, yes. So, but the question is, how many BMWs are driving in 15 years on our streets? Because we can drive with so much cheaper things. I mean, traffic, train, bicycles, and everything. Yes. So is the demand going up or down, or you close this gap with probably services or expensive services?
What's for me clear is, and I think that we all in the room totally agree, that individual mobility will increase, and you do not want to wait elsewhere for half an hour that a car is coming, taking you, and you have to go to the next station and wait once more an hour, and so on. Individual mobility is increasing dramatically, and I want to go fast from one point to the other point, and this drives more or less all of us, I think. The question, if we do have then 75 million cars worldwide or not, I think this will show, because when I see the last 10 years, or just take 20 years ago, a normal family in Europe had perhaps 1 car. Currently, a family with 3 or 4 members, and the kids are a little bit older, they have 3 or 4 cars. Nobody thought about just 15 years ago that one family could have 3 or 4 cars. Why? Individual mobility is increasing dramatically. And we'll see what happens to the automotive industry, but also then to BMW.
Even though it's an interesting aspect of how many cars do you have in the family. My son will be 20 within a few weeks, and he doesn't even have an idea of acquiring a driver's license. He is not interested in that. His concept of mobility is in the Stuttgart area.
And where in Stuttgart?
Even in the outskirts, so you have to wait half an hour for the S-Bahn there.
So I live also in Stuttgart. I know in this age, and we had just a discussion 2 weeks ago with students, 20, 25 years, when you are 5 kilometers from the S-Bahn, and you have to drive with a bicycle, and
then
after 8 o'clock in the evening you have no bus, then you know what your son is doing when he wants to go to Stuttgart to the disco.
Right.
You are driving, and you are the autonomous driver.
It's steady taxi. I know.
Or your son will get a...
Or we will finish on time so that he can get the autonomous car. But the point is, where I wanted to go, you said that the future is not black and white, it's in gray. I would even say, sorry to put it that way, it's very colorful. because mobility will have many, many more aspects and variants than we have it today. So obviously, and the discussion we're just having shows it, obviously for my son there is an option of not having a driver's license, well, as long as daily drives if it's necessary, yeah. But people will have different ways of how they move.
Right.
And in the future, imagine this world where you not only take your smartphone and check how you get from A to B, but at the very same time you can just click on it, and with some apps you're pretty close to that already, and say, okay, I want to get from A to B, and you get a proposal which is the best mobility service you can take. So you hop on the S-Bahn, you go to the station, then you take the train, you arrive here in Vienna, and when you just step out of the train station, there is already the autonomous taxi waiting for you because you booked it hours in advance, and that takes you here to the convention center. And since you already planned your schedule more or less, when you go out, there is your taxi taking you back to the train or to the airport. There is so much more of potentials and ways of how can we move individually that we will change the complete way how cities look like.
Totally agree.
Right.
For the first thing, if your son would live in Munich, then he would have a BMW, so he would have a driver's license.
No. Well, I can talk from my daughter. She is 25, and she studied in University of Munich, and she lived in Schwabing. She said, I do not want to have a car. Now she has a driver license. Then she made a practicum, or she worked 6 months for ZF at the Lake of Constance. And her flat was in Meersburg, only 10 kilometers, 50 minutes, with an e-bike from Bosch, no problem. But sometimes it's raining.
By the way, it's connected.
Sometimes it's raining. And then she said, well, it's really difficult to come from Meersburg to Friedrichshafen. It was really, with commercial vehicles or with buses, very difficult. So she said, well, a car is not too bad. So I think the world is grey, and there are regions where you will have no car in future because you have no garage or anything else, and you will have regions where you are happy if you have your own car.
Okay.
So you're right.
Please.
The world is now grey. It have to be green. But one question again for me would be important. How many value have a brand on a car? Because if the digital platform, whatever it is, yes, offers me the best and fastest and safest way coming from A to B, is the question, how important is the brand? That would be really...
Absolutely,
probably nobody can answer it, but it's really one question for all those digital guys outside to probably, what is the value? What is...
I think we will have a value in the brand. The question is, what is the DNA of a brand in the future?
While we finish up this round here, and I'd like to first thank the panel. Thank you very much. I would like to put your attention to the screen here, and these are questions that are coming here from the audience. So let's pick up the first question, because I think it's a very nice provocative question. It says, how do you plan to catch up with Tesla? Tesla almost has the autonomous car ready. So maybe...
You are allowed to answer.
You go first.
Why are you handing that to me? I'm only providing you the technology, so you have to know how to catch up.
You are my sixth project with your colleagues in Sindelfingen, so you can answer.
Well, taking this project, I think we're targeting at different topics. So one thing is how to more and more give automated driving facilities to the usual, let's say, privately owned or used car. That is the Tesla model. And I would say that is kind of that is technology which is advancing step by step. As I said, you already can see such kind of technologies on the market. Tesla is one of the examples. You know as well, in a Tesla car, you should pay attention to what the car is doing and not leave it completely to the car, what is going to be done. So that's a clearly level 2 function. The next step, and I see many OEMs working that way, is the level 3 function, as I said. What we are doing, when you reference to my current job, is complete other field That's not the private car. That is a shared vehicle owned by a company providing mobility service and giving taxi services. So the question how to catch up is not the question how to catch up with Tesla. It is the question how can you make as fast as possible a technology which provides you with this autonomy, but, and this is one of the key statements that we do, make it safe.
Yes.
We want to make sure that when you sit into our car, you will be in absolute good hands. And that means there's a lot more than just, and I'm not negliging now the software work, that's just making the driving software. There's so much under the hood, which is making a stable EE architecture, making a stable sensor set, making a stable actuation set, making a stable basis where you can put the functional software into. This is one of the very, very crucial points. So how to catch up, make a very solid basis, and then have a solid basis ready to put a good software on it at the end of the day.
Walter, maybe you can take the one about how can we avoid more or less double traffic if cars can move without persons in and to park outside of the city. So, I think about, if you have a lot of electric vehicles, how do you basically manage that infrastructure without having, the city crowded with all these potential cars that can be used? I don't know whether somebody has seen, there were pictures in the internet the other day about China, about these gigantic piles of bicycles, because there are so many companies providing, these shared bicycles. But the cities, meanwhile, when they're not properly managed, they take them and they put them on a junkyard, and it's like gigantic pile. So how do we avoid the situation with cars, and especially in the electrified environment?
It only can be solved with software, but this is hard to answer. I mean, this is not only one question, because if a car drives autonomous cheaper because it drives faster, then it will all autonomous cars will drive really fast. That means even if you make more value or money on it, you have to drive it always faster. So that means that and then if you drive a car fast into your parking lane, I don't know, this is really hard to answer.
It's to be developed and to be seen, right? What concept will take
I mean, there are many mathematics on it to calculate cases which give us the answer. I mean, I don't know.
Klaus, there's the question comes in. You spoke about moving to a tech company. You said this. What are the key requirements?
Well, I would say, well, it's a question, how do you define software device with wheels, vice versa? Well, in the car, just take our PLCs in the car, we have approximately in a 7 Series 90 computers, 90. And when you see 90 computers, and with autonomous driving and electromobility, more computers are coming in dramatically. So it's more or less a theoretical discussion. What is it more software with wheels or wheels with software? What we see is, and we all of us here on the panel see, that IT is getting more and more important, or is at the end of the day perhaps priority one in the car, to get priority one, a secure mobility, a safe mobility, and to get these services into the car.
Okay. Could a combination of blockchain and IoT help to achieve the perfect environment for driverless cars? And if yes, how? The question is more like, maybe if we abstract it a little bit, does blockchain play an active role today in your
well, we have several use cases with blockchains in the car environment. Just take used car, for example. What we have in some areas of the world, problems that the mileage number which you have in the car, so perhaps here in Europe, is not the one what it should have. And for example, with blockchain, you have a transparency, and you have get the trust how much mileage or how many mileage the car really has, and the customer is happy because this mileage I pay for it is the right one. So this is a first use case, but there are several also in the car.
Must apply to batteries as well, like aging of the battery and all of that, right?
Exactly. Safety, aging, insurance things. There are many things on it, but I think complicated thing, and it's interested probably for the DevOps outside here, is if a car had an accident, how you can trust if the software is original or is hacked. Because it's the last second where a car was online and it crashed. And the question is, what happens between the crash and the time where the black box is coming out of the car? Is this software original or not original? I mean, this probably is one of the biggest things. We solved these problems. We try to solve this problem of the battery as well in the blockchain field to guarantee the originality, to guarantee the BMS informations, because that's very important to guarantee the cycles. But all the way on how we can be sure that it's not hacked, but that's a very hard thing. If you make the architecture for it, then you need 2 black boxes or what more. So I think blockchain is very important for the car.
Michael, at Bosch, the blockchain technology.
Obviously, we're taking a look on what can you do with blockchain technology. Obviously, to have secure and unmodified information available is one of the very crucial things. I said the car will be part of the IoT. And one of the key essentials is to have, for example, very, very valid information about the environment. That is this high definition maps or highly automated driving maps, what you have. So we do evaluate how can we generate information in order to update maps and transmit this information in a secure way. And the other way down, how do we get authentic data from a cloud server down and be sure that comes really from the one I asked to send me the information, and this information is not manipulated. So obviously that has a certain potential. It's not the only potential that we do have. We, since many years, are working in security technologies, acquired in 2012 company eScript in order to be more competent in communicating securely between control units. So that's one of the technologies. Others is hardware-driven, like HSM.
I mean, there's blockchain technology exposed here in the show, so which is a very software-driven topic, 100% software, next to the electricity you need to actually, for example, calculate new coins, which is another very, very fascinating topic. I think we can maybe close it down here. The clock is running out. I think this was a very interesting discussion. I hope that you as the audience had some kind of interesting takeaways, and thank you very much. Thank you.
Thanks.